I'll be done, and you guys. This is going along with Riemann sums, and it's how to do basically an integral using the limit process. And Riemann sums, if you realize we have a width and a length, I actually call the length the height, and the width is sometimes called the base. But I hope you remember on a Riemann sum that we get each base of the rectangle is b minus a over n, where a and b are the intervals. And then the length is the height of each one, and this is the formula to find it, the function of this. Now this a right here, that a is the same as this a. It is the original number that we are doing as we go through this problem right here. So we are going to, like I said, I already did a video for 6. We're going to come down here and do 7, but we're using this stuff up here. Also, I talked about in previous videos, I always recommend you do a right endpoint, which is a right Riemann sum instead of a left, because in a left, you have to put I minus 1, and that causes extra foiling, which takes extra time. This one, it just has an I, is way easier. So I would not do this unless directions made me. So I'm always going to do a right one over here. So we're going to go through and we're going to do this problem down here. So I hope you can see that this is my A and my B right there. That's my A and my B, and I'm going to come up here and do some of this and down there. So I want to get my width. So from up there above, the width is going to be B minus A all over n, so my width is 1 over n. The length, which is also up there, is your A value. Well, it's f of your A value. Well, your A value is at 0, so that's not really going to affect anything. Plus, and then it's B minus A over n again, so that's still this 1 over n. And then we also have an I with that. And again, I'm getting this stuff right here from up here in these notes. This stuff right here. So all I did was plug in the numbers from this number 7 down here. So now what I want to do is I want to find out what f of this value is. In other words, I'm plugging this in. And if I get 0 plus this is going to be f of I over n, because I times 1 is I, and over n. And then this says, this y right here, that y is my f of x. That y is f of x. And it says it is x cubed. So when I plug I over n in for this, and I'm going to do my summation notation, I'm doing the limit as n goes to infinity, which means I'm doing an infinite amount of rectangles. And then I'm going to do the summation as I goes from 1 to n, which I hope you see is actually going 1 to infinity. And then I'm going to take I'm going to go ahead and do my length. So I'm going to stick this in for this function. Actually, I think I'm going to do this right here. So this is going to be I over n to the 3rd power, which is going to be I cubed over n cubed. So when I take my length, which is I cubed, over n cubed, and I take that times my width, which is 1 over n, I get this right here. And because my index is I only, that means the only thing that's a variable over here is I. Everything else are constants. So what I can do is I can multiply these straight across, and I'm going to take everything that's a constant and stick it in front of the sigma. So this is going to equal the limit. And I can't put it in front of the limit because there are n's in it. I'm going to put that 1 over n out front with this n cubed. So this is going to be 1 over n to the 4th. And then I got my sigma notation of I equals 1 to the n of I cubed. Now I'm going kind of fast here, so if you need me to slow down or you got a question, throw it out there. It just so happens that this thing right here, the summation of I equals 1 to n of I cubed, is in that first page, the formulas, which I moved right before this to save some time. This is the summation of I equals 1 to n of I cubed. So I can rewrite this as this thing right here. So I'm going to stick this in for the summation of I cubed. So when I do that, This is going to equal the limit, and then goes to infinity, and I've got this 1 over n to the 4th out here, and then I'm going to stick in that other stuff for I to the 3rd, which I'm going to go back and show you again. It's n squared times the quantity n plus 1 squared all over 4. Okay, so we're going to plug that in. So I got n squared times the quantity n plus 1 squared all over 4. Now what I got to do is I got to simplify all this stuff right here. So I'm going to do algebra. I think I'm going to come on down here and do it below. So I'm going to leave my limit as n approaches infinity of my 1 over n to the 4th. And then I'm going to go ahead and start multiplying. So I've got an n squared out here, but I need to do this binomial square. So n plus 1 times n plus 1. There's a shortcut to that where you square the first term times the second term times 2, and square the last term. You still got that 4 there, and then I'm going to go ahead and multiply the top part. So I'm going to get the limit as n approaches infinity. And when I multiply that n squared in through there, I've got n to the 4th plus 2n cubed plus n squared. And I'm going to multiply this n to the 4th times 4, and I get 4n to the 4th. Well, I hope you know that, again, this is a horizontal asymptote problem. So all I need are the biggest powers. So when the biggest powers are equal, you're supposed to know the limit as you go to infinity is the coefficient. So this whole value is 1/4. So in other words, the area of this problem right here of y equals x cubed from 0 to 1, so this right here, this area right in here is 1/4 units squared. So that's the same way as we would do an integral. So if you were to do the integral from 0 to 1 of x cubed dx right here, you would get the same 1/4. You can check it out and see what happens if you want. Okay, so that's that one. Did I start the video? Okay, good. Then we're going to do this one. Same story. Only this one's more math. But I'm going to do it the same way. This one takes more algebra, so this takes a little longer. So width, again, is going to equal b minus a. Well, here's your a, here's your b. So it's going to be 2 minus 1 all over n, which is 1 over n. He's so nice to make those ones, makes the math easier. And then to get my length, it's going to be f of a. Well, now a is 1, so that makes a difference. Because a is at 1 now, so that makes a difference when it's not 0. So it's f of 1 plus b minus a over n, which is this same thing that was up here, I. Okay? I'm doing the same thing I did a minute ago. Now I need to plug this thing into here to find out what this equals. So this is going to equal 4 minus, okay, before I do that, I'm going to get a common denominator because it's going to make my squaring something easier. So I'm going to make this n over n to get a common denominator. So this is going to be f of n plus I all over n. Because I times 1 is that I up in top. So I got n plus I all over the common denominator of n. And now I'm going to do my length value by plugging this thing in for this x right there. So my length is going to be 4 minus n plus I all over n to the 2nd power. So I'm going to simplify all of this before I stick it into the whole formula. So this is going to be 4 minus, square the first term, take the first term times the 2nd term times 2, and square the last term. And then square the denominator. And then I'm going to get a common denominator so that I can simplify this by multiplying this by n over n. N squared over n squared, because I need an n squared to get a common denominator. So this length is going to equal, we got 4n squared minus n squared, that's 3n squared. And then we got 0ni minus 2ni, which is minus 2ni. And then we got 0i squared minus I squared, so this is minus I squared, all over my n squared. Now that whole thing right there is just the length simplified. So to get each rectangle, it's going to be the width times the length. So the length is 3n squared minus 2ni minus I squared all over n squared times the width, which is that 1 over n that I found way back up here. And then to get the area under that, I'm going to do the limit as n approaches infinity. And I'm going to do the summation of that infinite amount of rectangles. From I going from 1 to infinity. Oops, I should put n there, not infinity. Okay? Now, I'm going to take this 1 over n and that n squared out front to simplify my problem. So I'm going to have the limit as n goes to infinity. And then I've got my 1 over n, but I'm also taking this n squared with it, so that's 1 over n cubed. And then I got the summation thing of I is going to go from 1 to n of this 3n squared minus 2ni minus I squared. Okay, I'm going to erase all that part at the top and go back to the top and start this again. I'm going to leave that last line there so I can see it, so I can do what I need to do next. Normally you just keep going down, but I got all that writing down there, so I'm just going to go back up to the top. Okay, so I'm going to now use this thing right here. Well, let me go back one more. I'm going to use this stuff right here, these properties, but I'm not going to actually write them out and put the summation down every time. What I'm going to do is I'm going to do the summation of this first part, and then the summation of this second part, and then the summation of that third part. And thinking about it, maybe, yeah, I'm just going to do it. So the first thing, I still got the limit because I'm not plugging infinity in yet. Infinity of 1 over n cubed. And then I'm going to start breaking this down. Well, 3n squared does not have an I in it, which makes 3n squared a constant. And again, going back to this problem right here, this formula, if you have a constant, you just take it times the top value. So whatever my constant is times the top value is what that equals. So when I do this, I'm going to take 3n squared times n. Well, that gives me 3n cubed. So that right there is the value of the summation of this 3n squared thing is this 3n cubed. Then I got minus 2n, and then I got the summation of I. Okay? Because remember, we can put the 2n in front of the summation. So I'm basically distributing this to all of these right now is basically what I'm doing. It's kind of like distributive property. So I got negative 2n in front of the summation, so I need the summation of this I. Well, that happens to be another one of our formulas back here, which is this one right here. So I'm going to put n times n plus 1 over 2n for that. So then I got this negative 2n times n plus 1 over 2. And then I got minus I squared. Well, I'm doing a summation of this. So that minus is that minus, and there's 1 for I squared also, which I guess I'll go back and show you. You're supposed to have these memorized, but I know you don't. That's this thing. So I got to put this whole thing in for that. So when I do that, I'm going to get n times n plus 1 times 2n plus 1 all over 6. Now I got to do, yeah.
On the minus 2n, is it supposed to be for the second exponent? Because you got to multiply it.
No.
The n.
This negative 2n is that negative 2n up there in the top.
So you don't have to multiply it by the n of like above the summation. like
No, the rule does not say to do that. I'm gonna go back over here to the rule and show you. The rule's right here. It says this part right here equals this thing, right? That minus 2n is actually the constant, so I move the minus 2n to the front of this sigma, and it's times just this. That's why I don't have another n. The reason this one is that way is it says take that top n times your constant. That's why we take it times the top n. This one is not the top n. This is just this part. All right, so now I got to do a bunch of algebra and simplify all this stuff. So here we go. First of all, I want to get a common denominator of 6. So I'm going to multiply this thing by 3 over 3 to get a 6 down here in the bottom. And I'm going to multiply this thing over here, if my pen will move. I'm going to multiply this part by 6 over 6 because I want a 6 in the bottom. I want a common denominator. So I still have the limit as n approaches infinity. And I still got this 1 over n cubed way out here. And I probably should have a bracket here and here too because it's the whole thing. I should put one there as well. And now I'm going to start simplifying this. So 6 times 3n squared is going to be 18. That's the squared, it's n cubed. 18n cubed. I got 6 in all my denominators now, so I'm only going to write one of these instead of all those. Then I got 3 times negative 2n is negative 6n. And negative 6n times that n is negative 6n squared. I'm going to distribute negative 6n squared to both of those. So that's going to be negative 6n cubed minus 6n squared. Last but not least, I got to do this one over here. And I'm going to FOIL these two together first. So I got n, and when I FOIL these two, I get 2n times n is 2n squared. N times 1 is n. 2n times 1 is 2n. And 1 times 1 is 1. I hope you see these two are like terms, so that's 3n. And now I'm going to take this n and distribute it to all three of these terms. So n times 2n squared is going to be, and there's a minus there, I got to distribute my minus 2. So it's going to be minus 2n cubed. And then minus n times 3n is going to be minus 3n squared. And then minus n times 1 is minus n. Oh, we're so close to done now. Then my next step is go ahead and multiply this times these, which is only going to change this bottom part to 6n cubed. Because 1 times all that keeps the same. Now I want to add all my like terms in the top. So 18n cubed minus 6n cubed is 12n cubed. 12n cubed minus 2n cubed is going to be 10n cubed. And then the rest really doesn't matter because it's a limit as n goes to infinity, but it's negative 9n squared minus n all over 6n cubed. So I hope you remember the rule is when you're doing a horizontal asymptote or have infinity, you look at the biggest powers. So this stuff does not really matter right there. And I hope you know it is the coefficients, which is 10 over 6, and then you would want to reduce that to 5/3. So the area of this problem would be 5/3.